Okay, I want to just cover some topics in each chapter that I believe most people at this level struggle with. Excuse me. Chapter 2, you're dealing with solving different types of equations and inequalities, things like that. So, just a couple things I want to talk about negative numbers, fractions, inequalities. One thing to remember, if you remember way back, probably fourth or fifth grade when you first started doing negative numbers. Well, your teacher probably, maybe drew a number line. Or maybe just listed them. And put your positives with your positives, your negatives with your negatives. Zero doesn't have a sign, it's neutral. But then after a while, what we do is we don't write the plus in front of the 1, the plus in front of the 2, and so on. We just assume that 2 means positive 2, 3 means positive 3, because positives have no effect on anything we do in math, but negatives do. So you don't need to worry if a number is positive. We just assume it's positive and we just multiply, divide just normally. But when you have negatives, you have to pay attention to that. And where I see most students making mistakes are with negatives. It's the details. Those are important details in math. You have to make sure that when you calculate with negatives, things change, signs change. And those little mistakes along the way cause you to miss the whole problem. So, math teaches you how to pay attention to detail. It teaches you to be organized, detail-oriented, follow directions. So, certain jobs also require attention to detail. I don't care what it is, construction, automotive, sales. You have to be detail-oriented. You can't just forget the details. So this is teaching you details, to pay attention to the details. So when we look at operations with negative numbers, and I'm just going to start with a basic distributive property type deal here. If I take 3 times 2x, well, everything's positive here. Well, I know 2 times 3 is 6. But then I have to have a sign here between the next two numbers because I do have an expression. Well, I take 2 times positive 2x, and that gives me a positive 4x. So what I do when I simplify or multiply or divide, whatever you want to call it as you're working through these, I multiply. Now, I could have said 2 times 3 is positive 6, but see, we don't write the positives in front of numbers that are by themselves or that start the sentence. But you have to put a sign in between the two numbers. So if I did the same thing here and then all of a sudden made this a minus 2x, well, I still take 2 times 3 to get 6. Then I take 2 times negative 2x, which gives me negative 4x. So you see how when I start doing my distributing, I do the multiplication and then I determine the sign and I write it down. So if I multiplied by negative 2, negative 2 times 3 is negative 6. So that you have to write down the negative 6 here. You don't have to write down the plus sign with the positive 6 because we assume it's positive if it doesn't have a sign in front of it. Then I take negative 2 times positive 2x, and again I get negative 4x. So let's do all negatives here. All right, and here's where, in the course of solving an equation, where I do see several stumbles. So just take your time. -2 times -3, +6. -2 times -2x is +4x. So you have to make sure, just take your time. Don't overcomplicate it. Most students like to overcomplicate math. But you have to pay attention to the details, and the details here are the signs. So if you were working a long equation, something like this, okay, you're going to be challenged on your details. So 5, you cannot subtract these two because you have to multiply first, order of operations. -3 times x is -3x. -3 times -4 is +12. I list the 6x. 7 times x is 7x. 7 times -4 is -28. Now, since I'm on one side of the equation, I combine like terms. So I have a +5 and a +12, a -3x and a +6x. The signs have to stay with the terms. Now I combine these two to get 17, -3 and +6. When you're combining like terms, you have a negative and a positive. You're theoretically subtracting the two. 6 is bigger and it's positive, so that gives me +3x is 7x minus your 28. Okay. Now I have to move all the x's to one side, everything else to the other side. So the way I do that is to add or subtract. I do the opposite. Well, this one, I see this messed up all the time. Remember, that's +17. So in theory, it's being added to that side. So to move it to the other side, I have to subtract it from both sides. So see, these cancel out. I'm left with 3x is 7x. Watch your signs here. Use your calculator. You got one, use it. -28 and -17. Since my signs are the same, I just add and keep the sign, and that gives me -45. Now I've got to move this 7x to the other side. I do that again. We assume we're adding it there, so we have to subtract it from both sides. And you can insert terms in between others as long as you keep the sign with what you had. So I have the -45, it's still negative. Again, these cancel out. 3 minus 7 is -4. X is -45. You can't just drop off this negative. It has to stay there. Then I take that, and so I'm solving for x, so I divide both sides by -4. So x and a negative over a negative is a +45/4. You can't reduce it. That's how you leave your answer for your test or your homework. Okay, so that's one area that I do see, mistakes all the time, is your negatives. And you just got to practice them. You got to pay attention to detail and follow the steps. All right. The next topic that I see issues with in just about all my classes are fractions. All right. Whatever happened to you along the way where you were scared off of fractions is unfortunate, but it happens. Don't be afraid, okay? 1/2 That just means 1 divided by 2. Okay, that's what that means. Put it in your calculator correctly. Many of y'all divide backwards. 1 divided by 2 into your calculator also means 0.5. All these things mean the same thing, just different ways to represent a quantity. And that's usually not a big problem. The bigger problem is, how do we multiply? Well, you know, you've multiplied fractions before. If I want to take 6 times 1/2, well, how do I do that? Well, there's several different ways you can do that. You can take 6 over 1 times 1/2, and then what we do is we reduce before we multiply. So I can reduce this by a 2 and that by a 2. And if you notice, what's all left are 1s. And I end up with 3. And that's the main process you have to understand in order to solve equations that involve fractions. So if I just took 6 times 1/2 x, well, nothing changes. Don't remember, x is just a number. It's out here to the side, but we can assume that it's really multiplied by the 1. But what we want to do is we want to do the same thing we did up here. And you can just break these all up if you want to. It doesn't really matter. Because, again, if I take a 2 out of both of these, I'm left with 3 times 1 times x over 1 times 1. The x, or the number always outside of a fraction, is multiplied by what's in the numerator. So this gives me 3x over 1, but we just write it as 3x. You always have to write things in their simplest form. And this is the simplest form. This is simpler than that. So anytime you have a 1 left in the denominator, you just get rid of it. Okay? And it doesn't really matter what I have. You know, let's change things up a little bit here. And let's say I had 8 times 3/4 times an entire expression. Well, nothing changes. Don't let the way it looks or the difficulty throw you off your process. You're still just multiplying these two numbers together. So if I look at here and maybe just separate your terms, maybe that'll help you. Again, I can take a 4 out of here, but I have to take the 4 out of the 8. And you notice every time I have 1s left down here. So I am dividing 8 by 4 theoretically to get 2. So what remains is I have a 2 times a 3 times the x minus 1 over 1 times 1. Well, I get 2 times 3, which is 6. Let's just start removing all my dots, and now I have 6 times x minus 1, which is 6x minus 6. So that's what you have to do. You have to be able to execute that. You have to be able to execute that. All right, so let's look at how do we solve an equation involving fractions. Well, let's just look at something like this. Let's say I had x plus 2 over 3 plus x minus 1 over 2, and let's just say this equals 1 over 6. Okay, looks intimidating, but always remember, when you're solving equations in math, you're doing opposite operations. I am taking x plus 2 divided by 3, x minus 1 divided by 2, 1 divided by 6. So I need to get rid of all this division at one time. So therefore, I have to find a number that is a multiple of 3, 2, and 6. Well, I want to find the least common multiple between 3, 2, and 6. So that least common multiple is 6. Because see, 6 divided by 3, and I know all y'all know this, is 2. See, I mean, sometimes we have to make things harder than it is. I know you know 6 divided by 2 is 3, and I know you know 6 divided by 6 is 1. So what I've done is I've chosen a number that all of these 3 can divide into, but it has to be the same number because I have to multiply both sides by that same number. You can't just multiply one side by 3 and one side by 6. You're changing the value of the equation. So then I do that. So I take 6 times, and I'm going to put this in parentheses just to group it. That's all. Okay, so think about what this looks like here. It looks like just what we did up here. So don't look at the whole problem. Look at one thing at a time. So what we did was we said, okay, I'm going to take 6 over 1 times x plus 2 over 3. I'm going to take 6 over 1 times x minus 1 over 2. And I'm going to take 6 over 1 times 1 over 6. Now I execute the division. That's where most people mess up. So remember, I take 3 out of 3, 3 out of 6. So what I have left here is 2 times x plus 2. I take 2 out of 2, 2 out of 6 to get 3. 6 out of 6 to get 1. 6 out of 6 to get 1. You notice I have all ones here. So if you're not working them like this and you're missing them, you need to do it. You need to do it the way I'm doing it. And that'll see, or let you see that, see, I have all ones here. And that means my fractions are all gone. And that leaves me just a 1. And so you then proceed and finish solving from there. Okay? So that's the second item that I see issues with, are the fractions and the negative numbers. So you have to start putting all these things together, and you know, a lot of things to pay attention to detail on. A lot of details. All right. One other item I want to look at are inequalities. Now, inequalities are your greater than, your less than, your greater than or equal to, or your less than or equal to. That means that they're not equal. It's more than something, less than something. That's what inequalities mean. So I want to look at interval notation because I see this all the time, these problems. Interval notation can sometimes look like a point. Okay? It can look like this. It can look like this. You can have parenthesis bracket. You can have bracket parentheses. So I know that can be confusing. But when we talk about intervals, think about intervals. It's between two numbers. All right, so if I had a x greater than 3, well, that means that I'm going from just bigger than 3 all the way to infinity. So in interval notation, I would list 3 with the parentheses because the parentheses means it does not include 3. So if I said I need more than 3, you're not going to give me 3. You're going to give me more than 3. But the first number bigger than 3 is not 4. So you have other numbers between 3 and 4. And that goes to infinity. And infinity always has a parentheses because it doesn't end. So if I had x greater than or equal to 3, then I would include my bracket. Same thing with the infinity. Let's say I had x is less than negative 2. Well, think about less than negative 2. On a number line, it's to the left of negative 2. In interval notation, we always list the smallest number first. So I go from negative infinity up to negative 2. That's less than negative 2. Does not include negative 2. If I had less than or equal to negative 2, I would go from infinity to negative 2 and put the bracket there. So you need to know the difference. You need to know how to list them. This just means between two numbers. Don't put an X in there. Okay, you've never seen anybody put an X in the middle. It's from this number to this number. Okay, now if I do have a compound inequality, and let's say I had something like that, well, this means that my solution for X is between two numbers. It's kind of like your grading scale. Your grading scale is between two numbers. 70 is a C, 80 is a B. So you think about it, a C would be 70 with a bracket up to 80 with the parentheses, because it doesn't include 80. And so that's what that means there, between two numbers. So for this one here, I would just put parentheses -2, 5 with the bracket, and that shows that my solution is between these two numbers. So if we're solving an inequality, we solve the same way we do an equation. The only difference is if I multiply or divide by a negative number, I have to reverse the inequality symbol. So for this inequality here, when I divide both sides by -3, well, that means I reverse my inequality, and that would be my solution. So on interval notation, it would look like that. Okay? So, just try to pay attention to your details. Try to pay attention to your details. All right, one other thing, there's lots of different types of formulas, word problems, things like that. But the best advice I have for you is you always choose your variable to represent one of your unknown quantities. Usually it's the quantity you know the least about. So you have to either draw a picture, whatever. So, if I had some type of equation where, let's say I have 2 pieces of wood, one is 3 more than twice the length of the other, and I'm just going to say the larger. Let's put it that way. Larger is 3 more than twice the length of the smaller. The length of the wood is 21 feet. Find the length of each piece. Okay? So that's kind of like, typical problem. So I know nothing about the smaller piece. Okay? I know nothing about it. So what I do is I let X equal the smaller. Now I have to write an expression about the larger piece. Well, I know the larger is 3 more than twice the length of the smaller. Well, X is the smaller length. So then 3 more than twice the width is the larger. So you write your two expressions. Okay. Now, what do I know? Well, I know the length of these two pieces has to add up to be 21 feet. So that's what I do. I know the smaller plus the larger is 21. Combine your like terms. Subtract 3 from both sides. Oops, hold it there. 21. 3x is 18. X is 6. Okay. Sorry about that. Kind of got ahead of myself. So this is 18 here. This is your 21. So I know the smaller is 6 feet. 3 plus 2 times 6 is 15 feet. So 15 plus 6 is 21. That's how you check yourself. Things got to work out. But you can't just, create ways for it to work out. It's got to make sense. Okay? So that's, something with the word problems. One other item with the word problems are our consecutive integers. Always let x is your first one. And then since they're consecutive, x plus 1 is your second integer, x plus 2 is your third, and so on. Okay, so if you're talking about 3 consecutive integers, well, this plus this plus this equals the total. Okay. Now, consecutive even and consecutive odd work exactly the same way. Because think about even and odds. They are separated by 2 numbers. So x is always your first. Then x plus 2 would be your second. X plus 4 would be your third, and so on. They all increase by 2 because we're basing everything on our first. So think about it. If I had 31 was my first, well, my next consecutive odd is 33. That's 2 bigger than 31. My next consecutive odd would be 35 because that's 4 bigger than 31. Okay, so you just have to, when you do these word problems, you've got to identify your numbers based upon x's. And then you have to create the equation based upon what your relationship is given to you. Okay, so that's going to kind of wrap up what I wanted to talk about in chapter 2. The chapter 2 topics. We'll move on to chapter 3 in the next one.